Okay, so today we are going to talk about 3.2, which is all over the quadratic equations. This is one of the bigger sections of our semester. This is kind of a cornerstone section where the information you use here will be used a lot moving forward because we're going to deal with quadratic equations quite a bit. So, a quadratic equation is always going to have the form of ax squared plus bx plus c equals 0. That's listed right here, where a does not equal 0, because if a equals 0, then we wouldn't have this x squared term. And then a, b, and c are all real numbers. The quadratic function is where we have f of x equals that ax squared plus bx plus c. The way that these look, these are one of our mother functions that we've talked about previously, or our basic functions, our basic graphs, where it is called a parabola. This U shape, whether it's facing up or down, is known as a parabola. And that is what a quadratic equation or function graphs like. So the one here on the left is just the basic function where it's x squared, so it opens upward. And if you have that negative out front, then it opens downward. As we learned from 2.5, that negative out front is a reflection over the x-axis. So everything that was on top flipped down to the bottom. And so we're going to learn a lot of different methods today on how to solve these quadratic equations. With that x squared, it's not just as simple as doing our addition and multiplication property and moving things over. We have to have some other tools. One of those tools is known as our zero product principle. And that states that if the product of two algebraic expressions is 0, then at least one of the factors equals 0. So another way of looking at it is that if we have a times b and that equals 0, then either a equals 0 or b equals 0. Both could equal 0. That's totally okay. But at least one of them has to equal 0 if we're stating that a times b equals 0. And so this is going to help us to solve the quadratic equations, because if we get them factored into binomials, then we can set each of our binomials equal to 0 and then solve for the x's there, and that will tell us where our quadratic equals 0, which is how we solve these. Another tool that we're going to use is something called the square root principle. The square root principle states that if x squared equals k, then x equals the square root of k, or x equals negative square roots of k. So another way of saying that is x equals plus or minus the square roots of k. There are times in your mathematical journey where you are only going to be concerned with what's known as the principal square root, which is the positive one. But as we are solving these today and moving forward, we're going to be concerned with both. Because if x squared equals 9, let's say, then x can be positive 3, because 3 times 3 gives us 9, or x could be negative 3, because negative 3 times negative 3 will also give us a positive 9. And so it's important to keep both of those answers lined up and not lose one of them just because we're used to just thinking about having the positive square root. So we have our zero product principle, we have our square root principle. Now let's talk about how we can solve these quadratics using factoring. This is one of the main methods you're going to use, and the tool of factoring is very important because you will use it later to solve this is quadratics, to solve polynomial functions and higher equations that are raised to the third, fourth, fifth powers, and so on. So factoring is kind of the reverse of FOILing. We've done the FOIL method when we multiply a binomial times a binomial, and that's where we take first, outer, inner, and last. Factoring is what we get going the opposite direction. So we FOIL to get to our quadratic, but we would factor to go from our quadratic to our binomial factors. So how do we solve equations or solve quadratics by factoring? Step 1 is you will always want to make sure that your equation is written as ax squared plus bx plus c equals 0. So you always want to have it in descending order with the x squared term first, your constant term last, and you want to have it set equal to 0. A lot of times your equations will already be given to you in this form, but if they're not, that is step 1. Step 2 is to factor. Step 3 is to set each of your factors equal to 0 and solve. This step we are able to do because of our zero product principle. Because when we factor, we're going to have something times something equals 0. And so using our zero product principle, we can set each of our factors equal to 0 and then solve those individual equations. Your last step, just like on any equation, should be to check your solutions. Today I have checked my solutions at least somewhat in the beginning on my notes, but as we work through them live, I probably won't check them, but I will reference that. If it's a test situation, I always strongly recommend checking your solutions. That way you're not accidentally getting the wrong answer by dropping a negative or something like that. So we are going to do 2 examples of solving quadratics by factoring. We have 4x squared minus 2x equals 0 is the first one that we're going to use. And you might think, well, there's no c. There's no constant here. And that's okay. Sometimes you won't have a constant term. We do have our x squared term, and if we don't have our constant term, that's okay. That just means our constant term is 0. So we're not going to factor this into 2 binomials like the reverse of FOIL. What we're going to do is we're going to look at each of our terms, the 4x squared and the negative 2x, and we're going to ask, what do these 2 different terms have in common? Well, 4 is the same thing as 2 times 2. And then 2 is 2 times 1. So they do both have a 2 in common. So I'm going to factor out a 2. And then I'm going to make sure that they don't have anything else in common. I have an x squared and an x. So they do both share an x as well. So I'm going to factor out a 2x. And when I do that, I need to ask, okay, 2x times what gives me the 4x squared? Well, 2x times 2x would give me the 4x squared. And then 2x times what gives me a negative 2x? Well, it's a negative 1. This type of factoring, where we only have 2 terms, or it can be more terms, and we pull out what they all share, is the reverse of distribution. Because if I am checking to make sure that I actually factored this correctly, I'm using my distributive property to make sure that I get back up to the original. Now I have something times something equals 0. So I can use my zero product principle. I can say, okay, well, either 2x equals 0 or the 2x minus 1 has to equal 0. Because I'm saying that when I multiply them together, I get 0. So then I solve each of these equations to figure out where that happens. Well, I would divide both sides by 2, and I get x equals 0. And then over here, I would add the 1. So I get 2x equals 1, divide by 2, and I get x equals 1/2. So when x is 0 or when x is 1/2, those are the possible solutions to this quadratic equation. One way that you can see this represented as well is with a set. We've talked about sets before, where we list our potential answers like this. So your homework could ask you for each individual ones like this, or it could give you the curly brackets and ask you to list the possible solutions inside those curly brackets, because then you have a set of solutions. If so, you just list the different answers that you get and make sure you put a comma between each of those answers. All right, let's look at the next one. The next one, we have 2x squared minus x equals 3. Well, if we're solving quadratics by factoring, we need this to look like ax squared plus bx plus c equals 0. So I'm going to subtract the 3 over so that I can have everything on the left-hand side and 0 on the right-hand side. Now that I have everything on the left, I can start factoring it. And this is the one that we are going to look at it in terms of factoring into a binomial. So when you are factoring quadratics, you're going to set up your binomials like this. And then regardless of what this term is out front, this coefficient, I have an x squared here. So that tells me I'm going to have an x and an x in here, because when I do my first, I have to get an x squared. Now, I do need to include the coefficients for this coefficient as well. So I have to think of what are the factors of 2. And we're in luck because the factors of 2 are just 2 and 1. So I'm going to stick a 2 in front of one of these. I should have given myself a little bit more room. So I'm going to rewrite it. 2x, just so I have a little bit more room, and x. And it doesn't matter if I put the x here or the 2x there. None of that matters. Now, the next thing I need to know is I need to know if I have positives or negatives in here. Like, what sign do I put in here? And in order to figure that out, I look at the sign here in front of my C. And this is a good thing to note. So, star, if the sign in front of C is negative, then the signs inside the factors are different. Meaning you're going to have one that has a positive and one that has a negative. The flip of that is if the sign in front of C is positive, then the signs inside the factors are the same. If the sign in front of C is positive, then the sign inside is going to be the same. Well, how do you know which one? You look at the sign in front of B. So if the sign in front of B was positive, then you would have positive, positive. If the sign in front of B was negative, you would have negative, negative. So that's kind of a helpful little cheat to figure out what kind of signs go inside of our factors. I'll try and address that as we continue to solve these and point that out to you, because it is helpful so that you're not doing a lot of guessing and checking. Because one of the things that comes with learning how to factor quadratics, especially when we're factoring them down into binomials like this, is there is just a lot of guessing and checking and playing around with different options. There's not always just this is exactly how you do it. And some students really don't like that because they can spend a lot of time on a specific problem. Factoring is definitely one of those tools, though, that the more you use it, the easier it becomes. So if it's difficult at this front end, just stick with it. Use your homework as a tool to help you by clicking that similar exercise button, and keep practicing, because the more of them that you do, the easier they will become. And you'll start seeing the patterns and all these little helpful things. And I'll give you as many of these helpful tricks as I can as we move throughout this semester. Okay, so I'm going back over here. I had 2x and x, that gives me my first term. Then I was thinking about what signs to put in here. And since it's a negative in front of my c, that means I'm going to have a positive and a negative inside of here. Now, I don't know which one goes where. That's where some of the guessing and checking happens. So I'm going to lightly, and probably in a different color, I'm just going to put a negative and a positive. That may be right, or it may be wrong. We're going to have to play around with it. The way we figure out what goes in the last spot inside of our binomials is we look at our c, and we're going to put factors of c in here. The nice thing about this problem is that 3 only has one set of factors. It's 3 times 1. So either I'm going to put 3 over here and 1 over here, or I'm going to put 1 over here and 3 over here. So let's look at what happens if I put a 1 and a 3 like this. When I start to FOIL, because that's how you check to see if you factored correctly, I do my first and I get my 2x squared. Then I do my outer and I get a 6x. and I do my inner, which is a minus x. If I do 6x minus x, am I getting to a single negative x? And the answer is no, I'm not, because I'm getting to a 5x. So I know that this one is actually not correct. So I'm going to try flipping so that I have 2x minus 3 times x plus 1, like this, and seeing if this works out. If I FOIL, I do my first, which gives me my 2x squared. Then I do my outer, which gives me my 2x, minus my inner, because it's a minus 3 times the x. So I have 2x minus 3x. That would give me this negative x in the middle. So this is actually factored correctly. So there is some trial and error when it comes to factoring. But now I have something times something equals 0. So just like up here on our other problem, when we had something times something equals 0, we set each of our somethings equal to 0 and solved. I'm going to set each of my binomials equal to 0 and solve. So I'm going to have 2x minus 3 equals 0 and x plus 1 equals 0, and I'm going to solve for my x's. Add that 3 over, divide by 2, subtract the 1, and I get x is negative 1, or x is positive 3/2. So again, if I was writing it as a set, I would have the set of negative 1, comma, 3/2. Okay, we're going to do another example. It's not quite factoring. This problem specifically is going to state, I'm going to just turn it sideways because it doesn't take up a lot of room. The example. Solve using the square root principle. Just as a quick reminder, the square root principle was this one in here, where if we have x squared equals some constant, we can solve for x by taking the square root of both sides. That's what we're doing. We just have to remember that we get a negative and a positive square root. Okay? So this one is 2x squared minus 10 equals 0. This is the one that's asking us to use the square root principle. Notice this one is different than our first one, because our first one we had the x squared and the x terms, not the constant. For the square root principle problem, we have the x squared and the constant, we don't have that x term. And so that's why it's beneficial to use the square root principle. And I did say that we're going to learn tons of different ways to solve these quadratics today. If a problem is very specific on how it wants you to solve it, or if it says solve by factoring or solve by using the square root principle, then 9 times out of 10, that is actually the easiest method to use for solving. So I would go with whatever method the problem asks you to use. So if I'm using the square root principle, then what I need to do is I need to get the x squared by itself. So I'm going to add that 10 over so that I have 2x squared equals 10. I'm going to divide both sides by 2 so that I have x squared equals 5. And then in order to solve, think of it kind of like doing the opposite. The opposite of a square is a square root. But the key here is to do the plus or minus outside. 5 is not a perfect square, so there's nothing for me to simplify there. I'm just going to have plus or minus the square root of 5. Do not give a decimal approximation unless it asks you to. Almost always it's going to ask you for an exact answer, and it's going to even tell you to leave it with the square root symbol. So this is the correct answer. I believe you are allowed to use the plus or minus symbol in the homework. If you are not, then you would have to list these separately. One word of caution is make sure that you're not underneath your radical when you hit your comma, or it will count you wrong. You want that comma in between, not under the radical. But when it comes to a physical test with me, the plus or minus is totally fine in my book. So there we've solved 2 using factoring and 1 using the square root principle. Now we're going to learn another method that's known as completing the square. Completing the square is very important, the process for it. We use it when it comes to circles and finding the equation for a circle. The purpose of completing the square is to get a perfect square trinomial. What that means is when you get a perfect square trinomial, you have a squared plus 2ab plus b squared. And what happens is when you factor that, you get a plus b times a plus b. So you have a plus b squared. You have a perfect square. And so that's what's nice about completing the square. If you have a squared minus 2ab plus b squared, then what that factors into is a minus b times a minus b, which is a minus b squared. It's a perfect square trinomial. So how in the world do we get these perfect square trinomials? Well, we have to complete the square. And so the way that we do that, and it's going to sound confusing, and we're going to do a couple of them, and I think it'll make more sense. But this is what we do. We take half of the coefficient of x. So we take half of b. We square it, and we add it to our polynomial. That's our constant. We take half of b, we square it, and we add it to our equation. Now, this first example that we're going to do is not actually solving with completing the square. We're just going to do the process of completing the square so you can see how it is done. Okay? So we're not solving this first one. It is not set equal to 0. We just have an expression, and we are just going to use the steps of completing the square. And I think I can leave both up here because I can just slide this up a little bit. Okay. So it says complete the square for x squared plus 8x. Notice there is no equal sign, so we are not actually going to solve. We're just going to do the steps of adding the 1/2 b squared. Okay? So what we're going to do is I always, over here to the side, when I am completing the square, I'm going to write out what b is every single time. Remember that for our quadratics, we have ax squared plus bx plus c. So the b is the coefficient that's in front of your x. So b in this case is 8. Then I usually write 1/2 b. So half of b would be 4. And then I write 1/2 b squared. Well, 4 squared is 16. So when I am completing the square, I'm going to put plus some constant over here. And every time I do this, I do put the plus in the space because that reminds me that I have to fill that space in with the 1/2 b quantity squared. That's what's going to go in that space. And by making my list over here to the side, I just go down to the 1/2 b quantity squared, and it's 16. And that's what I'm going to put in order to complete my square. Because now, if I was asked to solve, which I'm not, but if I was, I could factor this because it's a perfect square trinomial. It would go into x. Notice this is a plus, so that means that I'm going to have the same sign inside, and the sign in front of my b is a plus, so that tells me I'm going to have a plus. And then what goes inside my factors is 1/2 b. That's why I make this list over here, because the middle term is what goes in my factors, 4 and 4. If I FOIL this, I get x squared plus 4x, which gives me my 8x, and 4 times 4 gives me my 16. This is what completing the square allows us to do, which is really, really nice as we move forward in solving. So, like I said, this first example we didn't actually solve because I don't have it set equal to anything. The next two examples that we're going to do, we are going to solve using completing the square. Oh, I guess I should give you the steps though. If you are a steps person, then here are your steps for completing the square. I did write them out in case you wanted them. So, if you are going to solve a quadratic by completing the square, it says, step 1, if your a does not equal 1, then you want to divide both sides by a. So this one's a little bit more specific because we need that a to be 1. And if it's not, we've got to make it 1. When we factor, our a didn't have to be 1. But when we use the completing the square, it needs to be 1. After that, what you want to do is you want to get all your variables on one side and your constants on the other. So again, this is different than when we factored. So we're going to have everything over here on the left-hand side that has an x term. And if you don't have an x term, we're going to move you over to the other side. Step 3 is where we actually complete the square. And that's where we're going to add the 1/2 b quantity squared to both sides. That is key. Both sides. You can't just add it to the left side with the x. We have to add it to the side with the constant as well. What that does is that's going to give us our perfect square trinomial on the left that we can factor. And once we have our perfect square trinomial on the left, then we're able to use our square root property or principle to solve our quadratic. Let me fold this down so we can still keep up the steps, but have the problem as well. So we're going to complete the square for x squared minus 6x plus 4. Step 1 is a 1. Yes, it is, so we don't have to worry about that. Step 2, we got to move our constant over to the other side. So I'm going to have x squared minus 6x, and then I'm going to subtract that 4 over, so I have negative 4. Now, I left a big gap there, and the reason for that is because when I complete the square, I have to add a 1/2 b squared in that spot. So I'm going to go ahead and put plus blank, and I'm going to put plus blank over on the other side too, because that reminds me that whatever I put over here on the left, I have to put over here on the right. I've had students who will highlight that so they make sure they fill in both spots, because one of the most common errors when completing the square is that you get caught up in doing the 1/2 b squared and you put that in over here and we forget to put it in over here. So this is a good way for us to be reminded that we have to put it on both spots. So now I'm going to look at what is b for this equation. Well, ax squared plus b, so b is negative 6. That means 1/2 b would be negative 3. And 1/2 b squared would be positive 9. Notice that whenever we are finding that 1/2 b squared, it's always going to be a positive, and that's because we're squaring whether or not it's a negative number or a positive number. When you square it, you're going to get a positive solution out. So that means I'm going to have a 9 here and a 9 over here. So when I factor over here on the left, I'm going to have x and x. This is positive, and we're supposed to get a perfect square trinomial, so these should have the exact same thing inside. Since there's a negative out here in front of my b, like what am I putting in here? I'm just putting in this step, remember? So I'm going to have a minus 3 and a minus 3, because what goes inside of here is the 1/2 b. Okay, so if the 1/2 b is negative, then it's going to be a minus inside. If the 1/2 b is positive, then it's going to be a positive inside. Then over here, I have negative 4 plus 9, which is a positive 5. So I have x minus 3 squared equals a positive 5. Using my square root property or principle, I would square root both sides so that I have x minus 3 equals plus or minus the square roots of 5. Now, I'm still not done. I haven't actually officially solved this yet because x is not by itself. I need to add that 3 over so that x equals 3 plus or minus the square roots of 5. And while you might not like that answer, it is actually correct. It is the most accurate answer because we left everything in terms of the square root. We didn't do any type of approximation. And so our solution set would be 3 plus or minus the square root of 5. So we're still getting two answers. It's just one of them is going to be 3 plus the square roots of 5, and the other one is 3 minus the square roots of 5. But we did just officially complete the square, and we solved that quadratic. So let's do another one. We're going to do 2x squared minus 1 equals 3x. This is not written in ax squared plus bx or anything like that. So what I'm going to do is I'm going to move this over. So I have 2x squared minus 3x minus 1 equals 0. Now, my a in this case is not 1. It's 2. So I need to divide every single term by 2. So that I have x squared minus 3 halves squared, or 3 halves x minus 1 half equals 0. So I'm going to have x squared minus 3 halves x equals 1 half. I added that constant over to the other side. Then I'm going to put my plus blank plus blank. Now our b in this case is a fraction. That's okay. This is one of the reasons why I make my little table or listing of my b's though over to the side, because it makes it easier to keep track of what's going on and what I'm going to put where. So I have my b in this case is negative 3 halves. So 1 half b, that would be 1 half times this, would give me negative 3 fourths. And then if I take 1 half b and I square that, then I'm taking negative 3 fourths times negative 3 fourths, which will give me a positive 9 sixteenths. So that's what goes in to these blanks. And you might be looking at that thinking, oh my goodness, if I look at this quadratic over here on the left-hand side and I need to factor that, that is super intimidating. And it would be, except that we have a perfect square trinomial. So there's actually very minimal thinking that needs to go into how we factor this. Because what happens is we're going to have x, and then we're going to stick in our b. So it'll be minus 3 fourths, and that's quantity squared, equals, now we do need to do some algebra over here to add 1 half to 9 sixteenths. 1 half, if I get a common denominator of 16, I have to multiply the top and the bottom by 8, meaning I would have 8 plus 9, which is 17 sixteenths. Do the square root principle, so that I have x minus 3 fourths equals the plus or minus square root of 17 over 4. 16 is a perfect square, so I can take the square root of the bottom. If the bottom had not been a perfect square, then I would have to rationalize the denominators, because you cannot leave it where you have a radical in the denominator. So I would have had to do that. But in this case, it rationalized out. It was fine. So I'm going to add that 3 fourths over, and since they have the same denominator, I'm going to combine that into one fraction, to where I have 3 plus or minus the square roots of 17 all over 4. So your answers can obviously get more complicated. Just note that whenever we're dealing with the square roots, we are leaving them in the answer, because it is the most accurate answer that we have. All right, so we've learned how to solve quadratics with factoring. We've learned how to solve quadratics with our square root principle. And now we've learned how to solve them completing the square. Another way we can solve them is using the quadratic formula. If you do not have the quadratic formula memorized, this is you need to memorize it. There's lots of different tricks in how to memorize it. There's lots of different songs or mnemonics that can help you to memorize it. The one that I know kind of goes to Pop Goes the Weasel, and I am not a great singer, but the way it goes is kind of like this, where you have negative b plus or minus the square root of b squared minus 4ac all over 2a. And it has been at least 2 decades since my teacher sang that to me, and it's still stuck in my head. And I will embarrass myself and sing it in front of every class that I ever teach because it works for so many students. And it will be final exam time, and you will hear people humming it, and it really does work. So I don't care if you need to write it down 10,000 times, if you need to sing it, if you need to learn some other method, but this is definitely a formula you need to memorize. And one way that you can learn it is that every time you use it, write it down until you have it memorized. That's always a great way to do this. So we're going to do 2 quadratics using the quadratic formula. I didn't write out any steps for solving using the quadratic formula. If you like steps, then I would say step 1, make sure that your equation is written as ax squared plus bx plus c equals 0. This one is not our constant on the right-hand side, so I'm going to subtract it over so that I have 3x squared plus 2x minus 7 equals 0. Once you have it written like this, I would make a list of what a, b, and c equals, and then you do a plug and chug to solve using your quadratic formula. So I have a equals 3. I have b equals 2, and I have c equals negative 7. Now, I'm going to use my quadratic formula to solve. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I wrote it down because I'm using it. And now I'm going to substitute in the values for my a, b, and c, and then I'm going to simplify. And here is a word of caution. You may want to just type that bad boy into your calculator and punch it out. I would not do that because a lot of your answers are going to have radicals. Or you could even get a complex answer like the ones we dealt with in 3.1. And if that's the case, your calculator is really going to hate you because it's not going to want to do a complex answer. So do not go to your calculator for these problems. Do the algebra and write it out. So in this case, I need negative b, that's negative 2, plus or minus the square root of b squared. B squared is 4. Minus 4 times a, which is 3, times c, which is negative 7, all over 2 times a. So I just plugged in the values. Negative 2 plus or minus square root of 4. Now here, this is something you could use your calculator for if you really wanted to. You'd have negative 4 times 3, which is negative 12. Negative 12 times a negative 7 will give you a positive 84 all over 6. It's negative 2 plus or minus square root 80, or 4 plus 84 is 88 all over 6. Now you may be thinking, okay, well 88 is not a perfect square. You'd be correct, but let's see if there's any possible perfect squares in 88. So when I say perfect squares, I want you to think like 2 times 2 is 4. So 4 is a perfect square. 9 is a perfect square. 16 is a perfect square. And in this case, 88 is divisible by 4. 88 is the same thing as 4 times 22. And since 4 is a perfect square, we can pull it out. Square root of 4 is 2. And then look what we have. We have a negative 2, a 2, and a 6. Those all share a 2, so we can simplify that to negative 1 plus or minus the square root of 22 all over 3. One thing you don't want to do is you don't want to say, well, 2 and 88 and 6 all have a 2 in common and try and cancel it out that way. You can't do that because the 88 is residing underneath that radical. Only if you're able to simplify the radical sum and pull out a coefficient can you then look and say, okay, do they all have something in common that I can simplify? -1 plus or minus the square root of 22 all over 3 is the correct answer, and we did just solve this quadratic using the quadratic formula. All right, let's do one more. We're going to do x squared plus 5x plus 8 equals 0. So again, I'm going to list my A, my B, and my C. My A in this case is 1, my B is 5, and my C is 8. X equals -b plus or minus square root of b squared minus 4ac all over 2a. So I'm going to plug stuff in. -b would be -1 plus or minus the square root of b squared. So, b, sorry. That's a 5. B squared would be 25 minus 4 times a, which is 1, times c, which is 8, all over 2 times 1. And notice I don't do a lot of simplifying that first step. Yeah, I'll usually go ahead and figure out my b squared, but I usually write out everything else so I don't accidentally flip-flop some numbers, kind of like I did here, where I wrote down 1 instead of 5. So -5 plus or minus square root of 25. -4 times 1 is -4 times 8 is a -32 all over 2. -5 plus or minus the square root 25 minus 32 is a -7. And you might look at that and be like, wait a minute, there's a negative under that radical. And you would be correct. But we learned in 3.1 how to handle those. Because what this is saying is it's saying plus or minus the square root of -1 times 7 all over 2. And the square root of -1 is our imaginary unit, I. So we can actually take that square root of -1 so that we have -5 plus or minus I, square roots of 7, all over 2. Now, you can leave it like this, but as we learned in 3.1, usually what we like to do is we like to have our real parts, and then we like to have our imaginary parts. And so a lot of times you will see the answers for these split. I have no problem if you leave it like this, but you could also write it as -5 halves plus or minus square root of 7 halves I. Because remember, we usually write our real part plus the coefficient and then our imaginary unit. These are exactly the same answer, and I have no problem with either one of them. If you want to write it like we did in 3.1, then this is the way you would do it. I usually leave it like this. I believe your homework is fine with either one. So you can get complex answers. Don't just stop because you have a negative underneath that radical. You know how to handle that now, and we're going to end up using it. All right, there is one more topic in this section, and it's something called the discriminant. And the discriminant is a nice little tool. It's not how we solve anything. It's not solving the quadratic equation, but it does tell us how many solutions or the nature of the solutions to our quadratics. And that is something that's nice. So the discriminant is this b squared minus 4ac. And hopefully that's like, that makes you think for a second, because that's the part that's underneath the radical in our quadratic equation. Let me flip over so you can see. See, look, here's our quadratic formula. B squared minus 4ac is the part that's underneath our radical. That tells us our discriminant. That tells us what kind of solutions we are going to get. Because our quadratic functions can have either two solutions, it can have one solution, or it can have no solutions. And I drew some very generic graphs to kind of show you how this happens. Because when we are finding the solutions of a function, the solutions is the same thing as the zeros. And the zeros are the same thing as our x-intercepts. And so if our graph doesn't actually touch the x-axis, we're not going to have any x-intercepts. And so that's how we get no real solutions. So here's what happens. If our discriminant, what's underneath our radical, is greater than 0, so it's positive, then we're going to have two unequal real solutions. And that happens like this, where our quadratic is going to cross our x-axis in two different spots. Now, all of my pictures have the quadratic opening up. The same would be true, though, if the quadratic opened down. It would still hit in two different spots, okay? So if what's under the radical in our quadratic function is positive, you have two unequal real solutions. If what's underneath our radical equals 0, then we only have one solution. And this happens when our vertex of our parabola hits the x-axis. Again, if it opened down, it would be the same thing. It only touches in that one spot. Now, if we have what's under the radical is less than 0, so negative, like in the very last problem that we just did, then that means there's no real solutions. But there are two imaginary solutions. When we did this problem up here, we still got solutions. They were just imaginary. And that happens when we have our quadratic opening up and it happens above the x-axis, or we would have our quadratic open down and it would happen below the x-axis, meaning it's never actually going to cross the x-axis. So there's no real solutions. Notice, though, that when we do our discriminant, we don't actually find out what our solution is. We're just finding out the nature of our solutions. We're just finding out how many we're having. So these are mostly multiple choice. They do usually ask you what is the value of your discriminant, so you can find the actual number that your discriminant is, and then it will ask you what that tells you. Does that tell you you have two real solutions, one real solution, or no real solutions? And you select that option. We're going to, because there's three different, types of discriminants, we're going to do three different examples. Whoops, let me scroll down. We are finding the discriminant and then listing what that tells us in terms of the types of solutions we are going to get. So, how do you do this? Well, the discriminant is b squared minus 4ac. So we're going to approach these problems a lot like a quadratic formula, in that I'm going to make a list of what my a is, what my b is, and what my c is. And then I'm going to plug and chug. My a is 3, and my b is 4, and my c is negative 5. So for b squared, I'd have 4 squared, which is 16, minus 4 times a, which is 3, times c, which is negative 5. So I get 16, negative 4 times 3 is a negative 12, times a negative 5 will give me a positive 60. So I get 76. Okay? So 76 is the discriminant. The number itself doesn't actually matter. If I would have had positive 1 versus positive 1,000,002, it doesn't matter. The fact that it's positive is what's important, because this is greater than 0, which tells me I'm going to have two real solutions. Now, like I said, your homework and your quiz, they could ask you for this value. So, you do need to actually figure it out and do the algebra correctly to get the correct discriminant. But when it comes to us determining how many solutions we're going to have, the fact that it's positive is what's important. Okay, let's do another one. I'm going to list my a, which is 9, my b, which is negative 6, and my c, which is 1. Do b squared minus 4ac. So b squared would be negative 6 squared minus 4 times a times c. Negative 6 times negative 6 is 36. Negative 4 times 9 is negative 36 times 1 is negative 36, which is 0. When it equals 0, that tells us that we have one real solution. This is what happens whenever our vertex lies on the x-axis and we're only getting one solution. And since I'm showing you an example of each of them, you can probably logically deduce what's next, but I'm still going to show you what it looks like. A equals 3, B equals -8, and C equals 7. So in this case, I'd have -8 squared minus 4 times 3 times 7. -8 times -8 is 64. -4 times 3 is a -12 times 7 is a -84, which is -20, which is less than 0, telling me no real solutions, but there are two imaginary solutions. We would still get an answer if we were solving this quadratic using the quadratic formula. We would just have one that had a complex answer, one with our imaginary unit.